Today we're going to look at the term isoelectronic. So isoelectronic means atoms or ions that have the same electron configuration. So when we're doing this, we're going to focus on the main group elements. So you can see that I have a periodic table here with just the main group's elements shown. I also have listed across the top the number of valence electrons, which we looked at in the last video. So what this is depending upon what group we're looking at, for the main group elements, we know how many valence electrons are in those outer shells. And the goal with valence electrons is that all the main group elements want to have a full octet, meaning they want to have 8. So everyone's trying to be a noble gas. Okay, and this knowledge of the octet rule helps us figure out which most probable ion the main group elements will form. So will they gain electrons? Will they lose electrons? If they gain, how many? If they lose, how many? So on and so forth. Okay, so we're kind of tying everything together here. So the goal with isoelectronic is you'll often be asked a question where you'll be given different atoms or ions, and you'll be asked, are these atoms or ions isoelectronic with one another? Okay, so to figure that out, you could write the electron configuration of these ions and compare them, or there's always a shortcut way. So the shortcut way would be, first off, you need to recognize, what are you looking at? Are you looking at a neutral atom? Are you looking at a cation? Or are you looking at an anion? Okay, so when I'm talking about cation, C-A-T-I-O-N means I see a positive ion. So cations are the positive ions. Anions then would be a negative ion. So that these two up here, nitrogen with a 3- charge and sulfur with a 2- charge, would both be anions. So if you can identify cation versus anion, you can figure out what noble gas they're isoelectronic with. So when we're looking at cations, positive charges, these cations are going to be isoelectronic with the noble gas in the row above them. All right, so what does that mean? It's easiest to explain doing an example. So magnesium with a 2+, that's a cation because it has a positive charge. So find magnesium on the periodic table. It's right here in period 3. So magnesium then is going to be isoelectronic with the noble gas in the row above. So since magnesium is in row 3, that means it's going to be isoelectronic with the noble gas in the row above, which is row 2. So what noble gas is in row 2? I can follow all the way to where the noble gases are, which is this last column here. And the noble gas in row 2 is neon. So that means magnesium is isoelectronic with neon. Okay, let's do the other cation following the same rule. So potassium, the plus, that's a cation because it's got a positive charge. So I'm going to find potassium on the periodic table. There he is. Potassium is in period 4. And since it's a cation, we want to look at the noble gas in the row above. So we're going to look at the noble gas in period 3. So the noble gas in period 3 is argon. So that means potassium with a +1 charge is isoelectronic with the noble gas argon. Now let's try the anions. So what noble gases are the anions isoelectronic with? So nitrogen, since it's got a -3 charge, it's an anion, a negative ion, so it's isoelectronic with the noble gas in the same row. So when you're looking at the anions, which are always going to be, in this course anyway, the nonmetals, so these guys right here, they're going to be isoelectronic with the noble gas in the same row. So you're not looking at the row above anymore. That's only cations. You're just looking in the same row. So nitrogen's right here. It's got 5 valence electrons. That's why it forms the -3 charge, right? Because if it can gain 3 negatively charged electrons, it'll have a full octet. So, since nitrogen's in row 2, it's going to be isoelectronic with the noble gas in the same row. So the noble gas in row 2 is neon. Now let's try sulfur. Finding sulfur on the periodic table. Since sulfur's got a -2 charge, that's an anion, so it's going to be isoelectronic with the noble gas in the same row. So sulfur's in row 3, so it's going to be isoelectronic with the noble gas in row 3. So it's isoelectronic with argon. All right, so what this means is nitrogen with a 3- charge has the same electron configuration as neon. Okay, so let's write the electron configuration of neon. So this is neon here. So the electron configuration, little practice with that. Remember, we always start at the 1s. So row 1, hit the s block first. So it's going to be 1s2, brings us to helium. We're done with that row, so we go to row 2. So I'm in row 2, I hit the s block first. 2s2, 1, 2, brings me to beryllium. Then I'm still in row 2, then I hit the p block, because this area here is the p block. And neon is 1, 2, 3, 4, 5, the 6th one in. So this is the electron configuration of neon. And when nitrogen has a 3- charge, this is the electron configuration of the nitrogen ion. Because in order for them to be isoelectronic, that means they have the same electron configuration. So if you're ever approaching an ion of any sort, if you know which noble gas it's isoelectronic with, you can just write the electron configuration of that noble gas, and that will be the electron configuration of that ion as well. Okay, so let's do the same thing with the rest of them. We're going to write the electron configuration of sulfur with a 2- charge. And sulfur with a 2- charge, we said, has the same electron configuration of argon. So let's write the electron configuration of argon. So we're going to start the same way. 1s2 brings me to helium. I get to period 2. s2 brings me to beryllium. I'm still in row 2. I hit the p block. If I go to 2p6, I'm at neon, but I want to keep going, so I'm trying to get all the way down here to argon. So then I have to go to row 3 next, and we're going left to right just like a book. So when I'm in row 3, I hit the S block first, where sodium and magnesium are. 3s, 1, 2 brings me to magnesium. I'm going to keep going in row 3. I hit the P block next. And argon is all the way at the end, so 3p6. So this is the electron configuration of argon, but it's also the electron configuration of the sulfur ion. So let's take a look at that a second. So sulfur's here, right? This is neutral sulfur. So this is where I would stop if sulfur did not have a charge. But when we say sulfur has a -2 charge, what we're saying is sulfur now has 2 extra electrons. Since electrons are negatively charged, it would be a -2 charge on that. So if sulfur has 2 extra electrons, it's gaining, right? So we're going 1 extra electron, 2 extra electrons. So it gains 2 to have a full octet, making it have the same number of electrons as argon. Okay, looking at magnesium, so we're going to do that one next. Magnesium's here. But for electron configuration, notice magnesium has 2 valence electrons in its outer shell. But if it loses those two, because that's what this +2 is telling us, it's telling us it lost two negatively charged electrons. So if it loses two, gets rid of that one, gets rid of that one, now it has the electron configuration of neon, the noble gas in the row above. Okay, so the electron configuration of neon, we already wrote it up here. So let's just copy it. We don't need to do it again. Potassium is the same as argon, so potassium's here. It has one valence electron in its outer shell when it's neutral. When it loses that one valence electron, so it's losing one negative charge, it becomes a +1. So it loses that electron and is now has the same electron configuration of argon, has a full octet. So there we go here. Now, let's take this a step further. We said potassium plus has the electron configuration, same electron configuration as argon. Well, do any of these other ions have the same electron configuration of argon? Yes, sulfur does. So what this means is that K plus, sulfur 2-, and argon are all isoelectronic with each other. Because, by definition, isoelectronic means they have the same electron configuration. And if we check, because we wrote their electron configuration, yes, they do. They match up. You'll notice also magnesium 2+ and nitrogen have the same as well. So what that means is nitrogen with a 3-, neon, and magnesium 2+ are all isoelectronic with each other because they all have the same electron configuration. All right, so we're going to look at one more example in a slightly different way to try to solidify this concept. So I'm going to word it kind of how you would see probably in a homework question. So in a homework question, you'd probably be given 3 atoms or ions and you'd be asked which ones of these are isoelectronic with each other. So let's make a problem out of that. So let's do, we'll do arsenic with a 3- charge. Sorry. We'll do argon, throw noble gas in there. Let's do rubidium with a +1. Chlorine with a -1. And bromine with a -1. Okay, so here's a list of neutral atoms, argon, and ions. So ions are the ones with charges, the neutral atom is the one without the charge. So given all of these atoms and ions, the question I'm posing to you is which of these is isoelectronic with each other? So what that means is, do any of these have the same electron configuration? How do we figure that out? Well, we could draw the electron configuration of each, but that's going to take a lot of time. So instead, what I'm going to do is I'm going to go through each example and figure out which noble gas each ion is isoelectronic with, and then I'll compare the noble gases to each other. Because if they're isoelectronic with the same noble gas, that means they're isoelectronic with each other. Okay, so let's start with arsenic. So arsenic is right here in group 15. He has 5 valence electrons when he's neutral. So since arsenic is an anion, it's got a negative charge, it's isoelectronic with the noble gas in the same row. So arsenic's in row 4. So the noble gas in row 4 is krypton, Kr. So it is isoelectronic with krypton. Argon, well, argon is a noble gas. So I'm just going to rewrite Ar. Okay, so looking at these two, I know these two are not isoelectronic with each other because their noble gas is not the same. Okay, so if the noble gas matches, they're isoelectronic with each other. If the noble gas doesn't match, they're not. So now let's look at rubidium. Rubidium's way down here in row 5. Rubidium is a cation. It's got a plus charge. So cations are isoelectronic with the noble gas in the row above. Okay, so rubidium's here in row 5. So we want to look at the noble gas in row 4, which is krypton. So notice arsenic, anion, and rubidium, cation, have the same noble gas in common. So that means that arsenic and rubidium plus 1, these are isoelectronic with each other because they have the same noble gas in common. Let's keep going and see if any of the others match up. Okay, so let's look at chlorine. Chlorine is a -1 charge, so that means it's an anion. So it's going to be isoelectronic with the noble gas in the same row. So we just go one over next door, same row, argon is going to be its noble gas that it's isoelectronic with. So now these two are matching. So that means argon and Cl- are isoelectronic with each other. Okay, now let's see where bromine fits in. Do you think bromine's going to be isoelectronic with krypton or with argon? So what group is it going to be in? Let's see. Bromine's here in row 4. So it's an anion, negative charge, meaning it's isoelectronic with the noble gas in the same row. So we hop over 1, and krypton is the noble gas it's isoelectronic with. So it matches with rubidium plus 1 and arsenic 3-. So bromine -1 goes in this row. So these 3 ions are isoelectronic with each other because they all match with krypton. These 2, argon and chlorine -1, are also isoelectronic with each other.